Hey guys, welcome to eMath. Today we have a interesting differentiation problem that is quite challenging even for a Calc 2 student. So when you look at this question, right, you can see we have x and we have a, but don't worry because we are looking for dy dx, which means all the a's here are just constant. Does it make it sound better for you? Okay, so like I said, a are just constant. So if you look at the first term here, it is just like some constant times x. And when you differentiate x, it becomes a 1 and attached to the constant multiple. So it is just 1 over square root of a squared minus 1, right? Okay, minus. So the whole thing here is just a constant multiple attached to some complex function. Just copy it, 2 over square root of a squared minus 1. And if you notice, two of them actually have a common denominator, which means later on you can combine them into one term. I think so. Then what about this one? Okay, this is a real deal, yeah? This is a real deal. So I hope you know that the derivative of arctangent is 1 over 1 plus x squared. Okay, I hope you know this. And for this question, we need the chain rule version of it. So if we have a d dx of arctangent of u, where u is a differentiable function of x, then it is 1 over 1 plus u squared. By the chain rule, you need to multiply with u du dx. Okay, so the whole thing here is just our u. Okay, it will be 1 over 1 plus u squared. You just square the whole thing here. Sine square x over, I don't think I want to expand it now. Maybe we can cancel with something from du dx. I don't know, so I will keep it, which is a plus square root of a squared minus 1 plus cos x, and remember the square. Okay? Then next we need to differentiate this one. We have no choice but to use quotient rule. Quotient rule says that you need to, okay, let me clear some space here. Okay, so quotient rule says that you copy the bottom function, which is a plus square root of a squared minus 1 plus cos x, then differentiate the top function. You differentiate sine, you get a cos. Okay, so just cos x, then minus copy top function, which is sine x, then differentiate bottom function. Okay, like I said, all the a's here are just constant. When you differentiate, they disappear. The derivative of cos x is negative sine x. So just put it here, negative sine x. Okay, then over the bottom function square. A plus square root of a squared minus 1 plus cos x. See, I told you we can cancel out with something from du dx. Okay, so before we do anything, let me simplify this fraction first. Okay, let me simplify this one first because I don't like the layering, right? So when you want to combine this and that, usually we'll get a common denominator, right? And you know that when we get the common denominator, combine it into one term, you can flip it, right? So let me just okay, how should I do? This is just the thing. Let me copy it. Let me flip it first, yeah? So it is a plus square root of a squared minus 1 plus cos x squared. Okay, this one, okay. Then the bottom will just be, remember we have a sine square x, yeah? Okay, this one. Is it a plus? Yeah, it's a plus, right? Plus sine square x, right? And now, the reason why I want to do this is because I want to cancel out this and that. Okay? And now we have some trouble here, right? Because if I want to expand this one, I want to open this bracket square. I have 3 terms inside. We'll end up having a lot of terms. So I think I will do a substitution, which is not necessary. If you want to do without this substitution also can. But just to make my life easier, I will do a simple substitution. Let maybe alpha be a plus square root of a squared minus 1. Okay? The reason why I do this is because I want to collect all the constant, all the a's together, and also to make my life easier when I expand this bracket. Okay? So as you can see, this part here, oops, this is a plus square, okay? This part here, oops, this part here is just our alpha, right? And this is, what was it? Plus cos x, okay? And as you can see, we have another alpha here. Okay, this is also an alpha. So it is just, okay, let me copy all the stuff in front first. A squared minus 1 minus 2 over square root of a squared minus 1 times, okay, this is alpha, right? This is alpha. So you distribute the cos x, so you have alpha cos x plus cos square alpha minus become plus sine square x. Just now was cos square x, sorry. And I think you can see something already, right? Don't worry, we'll do it slowly, step by step. Okay, and at the bottom you expand this alpha plus cos x square, you get alpha square plus 2 alpha cos x plus cos square x plus sine square x. See, it is very nice. We can clean up a lot of stuff here already. Okay, then let me write it down for you. Okay, since we know that from the Pythagorean identities, sine square x plus cos square x equals to 1, which means this one here is 1, and this one here is also 1. So we can, okay, let me just copy it, this one very quickly. A squared minus 1 minus 2 over square root of a squared minus 1 times alpha cos x plus 1 over alpha squared plus 2 alpha cos x plus 1. Wait, this one, I thought I changed it to green already. Okay? Then now, I think I will keep the alpha. I will keep an alpha and I will unsub it later. Okay? Now I want to distribute this one into the square bracket and I want to combine the two terms. Alright? So I will have, we do it slowly, step by step, minus, you distribute the 2, you get 2 alpha cos x plus 2, and this one I will just leave it outside. Okay, okay, a squared minus 1, then alpha squared plus 2 alpha cos x plus 1. Okay, so now you want to combine the two terms together. You need to make sure that they have common denominator. So you have to multiply both top and bottom by this one so that you can combine them together, right? So now I will have alpha squared plus 2 alpha cos x plus 1 minus 2 alpha cos x plus 2. And as you can see, we can clean up a lot of things there, right? And at the bottom is just square root of a squared minus 1 alpha squared plus 2 alpha cos x plus 1. Clean up the stuff. Okay, alpha square is still alpha square. This and that can cancel. 1 minus 2 is minus 1. See, we are doing good, right? It's looking very nice. And what about this one? Okay, never mind. I will just copy it first. And I think it's time to cos x plus. I think it's time to change to unsub our alpha. Okay. So who was our alpha? Alpha was a plus square root of a squared minus 1. Okay, right here. Since alpha equals to a plus square root of a squared minus 1, and I think it will be easier if we try to square it outside, then we just plug it in. If not, we have to do a lot of messy work, right? Okay, let's square both sides. Alpha square is this one, you square. Okay, you square, open up the square. You have a square plus 2a square root of a square minus 1 plus square and square root can cancel out each other, so it is just a square minus 1. Okay, I don't want to confuse you. Okay, so I think I will write like this. What I did was I square both sides. Okay, so and I better put a bracket here, and I try to simplify this. 2a minus 1. Oh, we have 2a squared. 2a squared and minus 1. And you know what? We can factor out. We can factor out 2a, right? 2a, so a plus square root of a squared minus 1. And do you notice something? You notice that this is exactly the same as this one, which means this is just alpha. I don't know if that is useful. And wait, let me see. 2a alpha minus 1. If you put this one, if you notice, okay, okay. Let me write down for you. Alpha square is 2a. Okay, so 2a alpha minus 1. If you put this one in to here, okay, this one, okay, you focus on this one first, yeah. You have 2a alpha minus 2. Then you can factor out the 2. And if you put this one into here, you also have 2a alpha minus 1, and you have a 2 here, which means you can factor out the 2 again. And maybe this 1 and that 1 this negative 1, okay, this negative 1 and this positive 1 can cancel each other. Yeah, so I think we don't completely eliminate our alpha first. We just see how it works. Okay, so it will just be 2a alpha minus 2 on top, right? Okay, 2a alpha minus 2 on top, and then this one is, okay, just copy it, a square minus 1, then alpha square is again, okay, maybe I should use blue color for this, 2a alpha minus 1, right? 2a alpha minus 1, then 2 alpha cos x plus 2 alpha cos x plus 1. Okay, so this is actually 2 alpha minus 1 minus 1, and this is actually from our alpha square. Okay, then we clean up the stuff a bit. Okay, so it is 2, we can factor out the 2, so 2a alpha minus 1, right? Because this one is actually minus 2. Okay, minus 2. Okay, then over square root of a square minus 1, 2a alpha, this and that cancel, plus 2 alpha cos x, which we can factor out the 2. Okay, we can factor out the 2. Let me just write for you. 2 times a alpha minus 1, a square minus 1. We can factor out the, we can factor out 2 alpha. Then it is just a, right? A plus cos x. And these 2 and 2 can be simplified. We have a alpha minus 1 over a square minus 1, a plus cos x. Okay, then what else? We still need to get rid of alpha at the end of the day. So, I almost missed out an alpha here. This alpha, sorry, yeah, we have an alpha here. Cause you for now you can't factor out any alpha to cancel out each other. I thought we can like make it into something alpha, then we can get rid of all the alphas. But seems like we can't, so we still need to substitute back what is alpha. Alpha was this one, right? A plus square root of a squared minus 1. Okay. Alpha was a plus square root of a squared minus 1 over alpha was a plus square root of a squared minus 1 times square root of a squared minus 1 a plus cos x. I think this a plus cos x should be fine already, just that we need to clean up on top. Okay, a squared plus square root of a squared minus 1 minus a squared plus a times square root of a squared minus 1 minus 1 over a squared minus 1 times plus a squared minus 1. Are we doing it right? Okay. I think you can see it already, right? A plus cos x. This one here is exactly the same as this one, isn't it? Okay, in case it is not clear to you, a squared plus a times square root of a squared minus 1 over a squared plus a. I just rearrange the stuff, then open up this bracket, minus 1, okay, then a plus cos x. This and that can be cancelled out, which means the final answer will just be 1 over a plus cos x. That's it. Pretty interesting, right? So this is what we got for today. Okay, a very interesting differentiation problem. And if you would like to have more interesting math problem, you can click on my suggested video here. And that's all for today. Thanks for watching. See you guys in the next video.